All right, we're going to continue with chapter 16. Now, we've been talking about acids and bases, which we know are special types of solutions, and it depends on when water basically breaks down. They call it self-ionizing. Does it produce more water with one hydrogen, which would be H3O, which is hydronium? That's an acid. Or does it produce more OH, water with one less hydrogen, which would be your hydroxide, and that would be a base. So one thing to remember when we're looking at equilibrium constant, because an acid and base is the same thing, the H3O and the OH keep going back and forth, okay? And then they reach an equilibrium. So if you want to figure out what their equilibrium constant is, they equal a certain number, okay? There's a special equilibrium constant just for acids and bases. It's an ion product constant, which for water, it's K sub W. And the two of them, the concentration of hydroxide and hydronium, always equal 1 times 10 to the negative 14th. Always. Okay? That's what, so if I know what this one is, I can figure out this one. I just take this number divided by this number, and I get that number. Okay? So the constant, the equilibrium constant of water, when you're talking about acid and base, is always 1 times 10 to the negative 14th. Okay? So if I want to figure out if a solution is acidic, basic, or neutral, if you look here, the HO is higher than the OH. So the hydronium, water plus one hydrogen, we know equals this. So if it's higher than, if this is the higher one, of course that's going to be an acid. Okay, if they equal each other, then it's going to be a base. And I can tell if, in order for it to be, neutral, sorry, I didn't mean a base. If I want it to be a neutral solution, these two have to equal each other. And I can tell you their concentration is going to be 1 times 10 to the negative 7. Because if the two of them multiply together equal this, then they have to be 1 times 10 to the negative 7. So they both equal that. And here's a basic, and sorry I cut you off a little here. But in this one, the hydroxide is higher. Okay? So if you have more H3O or more hydrogen ions, that's an acid. If they equal each other, the H and the OH, that's neutral. This would be like distilled water. And then if you have more OH than H, that's a base. Okay? And so you have it, here's listed up here too. Again, we can determine this by their concentration. So when we're looking at this, remember they both always equal this. So if I know what this one is, I know they both equal this one, I can always find that. And again, I'll show you. Now, if I tell you the concentration is 2.7 times 10 to the negative 11th, is that an acid or a base? That's kind of hard to do. So what they did was they came up with a pH scale, and you guys have probably heard of pH scale before. If you don't know what pH stands for, it stands for the potential of hydrogen. That's why the P is little and the H is big. It stands for hydrogen. Okay, it's a way of reporting the hydrogen ion concentration. All right, now remember it was 1 times 10 to the negative 14th. Okay, so we use the logarithms of those. So then it makes a number from 0 to 14. The low numbers are actually acids. And some people think, well, wait a minute, if you're reporting the hydrogen concentration, shouldn't the low numbers be bases? Which, is, but now remember, it's 1 times 10 to the negative 14th. So 1 times 10 to the negative first is a bigger number. These are the bigger numbers, 1, 2, negative first, negative second, negative third. Their pH, if it's 1 times 10 to the negative first, is 1. That is a very strong acid. Okay, 1 times 10 to the negative second is 2 and 3 and so on. And so these guys down here, these are the bases. So basically, that sounds weird when you're talking about bases, right? 0 to 7 is an acid. When you're at 7, it's neutral because they both equal each other. And then above 7 is a base. And that's how the pH work. And what it is, it's the log of the hydronium ion concentration. So 1 times 10 to the negative first, the log of that is 1. Okay? Neutral is 7. And again, what I just said, acid is from 0 to 7 or below 7 if you want to say that. Base is above 7. Okay? Only the digits after the decimal point are significant figures in logarithm. So what if it's not 1? Because see, the logarithm, if you take the logarithm of 1, it's 0. and then you take the logarithm of 10 to the negative first, that's 1. So that's why the pH is 1. But what if it isn't 1? Well, it's really easy, you guys. You just plug it in your calculator and it'll tell you what the number is, okay? So there are some other pH scales, okay? The P in, like I said, P is potential, tells us to take the negative log of a quantity, in this case, hydrogen, okay? There's also what they call the pOH system, which is pretty much the same thing, only now we're looking at the hydroxide. So it would be just the opposite. If your pOH was in the low numbers, that would be a base. And if your pOH was in high numbers, that would be an acid. So they're just basically flipped. Okay. All right. So how do they relate to each other? Now, again, we said the hydronium, which is water plus 1 hydrogen, and the hydroxide, these two concentrations equal 1 times 10 to the negative 14th, always. So if you know one, you can always find the other by taking this number divided by that number, and you'll get that number. Okay? We also can, using this equation, if we know the logs of the H3O and the OH and we want to find a different one, let's say we know they both equal 14, because again, this is taking the logarithm of this is 0, this is 14. Okay, so in other words, if I know the pH of the OH, let's say the pH of the solution is 4.7, if I take 14 minus 4.7, I'll get the OH. So you can use that scale as well, because they are the same. Okay, so because these guys always equal a constant, you can use them. If you know one, you can always find the other just by subtracting. So if I know the pH of a solution and I want to find the pOH, 14 minus the pH will give me the pOH. Or if I know the pOH and I want to find the pH, 14 minus that number will give me that. So it's a really simple system in that. Okay, so again, the pH plus the pOH always equals 14. Okay, and again, K sub W is the equilibrium constant for water. These two concentrations always equal that. And again, it's an equilibrium constant because if I'm forming more of these, I'm forming, they'll go back and forth just like we did just before this when we were doing the equilibriums. Okay, so find the OH when the H3O equals 2.7 times 10 to the negative 5th. Again, remember the two of them together always equal 1 times 10 to the negative 14th. That number never changes. So all I have to do is take what they equal, 1 times 10 to the negative 14th, and I divide by the one that I know. Okay, so if I take 1 divided by, now you guys, it's not 2.7 divided by 1. It's 1 divided by 2.7. So it's going to be a number less than 1. Please don't write 2.7. That's not right. And then you're going to subtract your exponents. Well, when you take 1 divided by 2.7, you get 0.37. And then 14 minus 5 is negative 9. If you left it like this, that would be wrong because that's not in proper scientific notation. So I'm going to move this over 1. Now it's in proper scientific notation. Because I made this number bigger, I make that number smaller. And negative 10 is smaller than negative 9. Remember, those negative numbers get a little screwy, but that's how it works. Okay? What is the pH of a solution? Excuse me. If the H3O equals 5.2 times 10 to the negative 11th. Okay, pH equals the log. So you can do what you can do is on your calculator, you can go log. Oops, mine you have to do the number and then log. Sorry. You'll have to discover what your calculator does because mine's a little different. So I write 5.2 negative 11 and then I hit log. And I get 10 point, it's going to be a negative number, you guys. I get negative 10.28. Okay, see the negative here? So they cancel each other out. Okay, that's all you have to do. So on mine, I wrote 5.2 times 10 to the negative 11th. Again, I've got, if you look, I got EE on my calculator. But you'll have to figure out how yours is. I think a graphing calculator, you have to put log first. Every calculator is a little different, so you'll have to figure out yours. The other thing you can do if you don't have a scientific calculator, if you just have a regular one, all you have to do is take the log of this number, go log 5.2, and then the log of this is negative 11. If you subtract those numbers, you'll also get 10.28. So there's, like, before we had really fancy calculators, and yes, I know that makes me really old. But what we'd have to do is we had a chart. We didn't have a calculator. We'd have a chart and we'd look on the chart and we'd find, 5.2, what its number is. And let me see if I can do that on mine. 5.2 log. The log of 5.2 is 0.72. Okay, this is 0.72 minus 11, and that's when you get the 10.28. So again, if you don't have a fancy calculator, just take the log of this number and subtract 11 and you'll get this as well. But it's kind of nice because most of our calculators, all you have to do is put in this number and hit log and you'll get that. Drop the negative because we got a negative here and a negative there. So what would this solution be? Well, if its pH is 10.28, that's going to be a base. That's above 7. Okay? And if I want to find the pOH, okay, then what I would do is I take 14 minus 10.28. Because the two of them always equal. The pOH and the pH always equal 14. So if I take 14 minus 10.28, the pOH of this solution is 3.72. And again, that would tell me it's a base, because remember, pOH, low numbers are bases, high numbers are acids. If we're doing pH, low numbers are acids and high numbers are bases. Okay, so that's where that came from. All right, what is the H3O of a solution with a pH of 6.35? Okay, so now we know what the pH is. We need to find the H3O. Okay, well, in order to do that, we have to take what they call the antilog, the second log if you're using your calculator. So now I got to go, oops. The second log of 6. So I go 6.35 second log. Let me see. 3.5 equals. No, that didn't work. Okay. Okay, so in order to get that, what you have to do, again, like I said, you have to go, oh, I know what I did. On your calculator, if you're doing this, you have to do negative 6.35, because remember we have that negative in there. So negative 6.35 second log. And I got a big, huge number. Negative, wait, 6.35 negative second log. Oh, there it is. So again, if you're going to solve these with, I just have a Texas Instruments simple calculator. It's probably easy on a graphing calculator, but I'm pretty sure with the graphing calculators, you got to do second log and then the number. On these, you have to put the number in and then do second log. But again, make sure you use negative, because again, remember we took the negative out when we did the problems the other way. So you have to put the negative in. If you don't, okay, so if this is what the H3O are, then what would be the OH? Okay, remember we said the H3O and the OH always equal 1 times 10 to the negative 14th. So if I take 1 times 10 to the negative 14th and I divide by, because we just figured out what this was. 1 divided by that, 0.224. 14 minus 7 is 7. Again, now we're going to have to move this over one more because we can't leave it like this. So it would be, make this number bigger, 2.24, make that number smaller. So from this, I can tell you what the H3O is, the concentration, and I can find, I already know what the pH is, but I can also find what my OH is. Then I could also find the pOH of that. I could do that one of two ways. I could either take 14 minus 6.35, which is probably what you do because that's the simplest, or I could find the log of this one. Either or, you're going to get the exact same answer. So if I take 14 minus 6.35, I get 7.65. If I take 2.24 to the negative 8th, and I do the log of that, I get 7.65. So either way, but honestly, 14 minus that number would probably be the easiest way to go. Okay? So again, you can do it either way. They all equal the same. The big thing to remember is they both equal 14. 1 times 10 to the negative 14th. We're just about out of time, you guys. That's why I'm going really fast. So anyway, that's what we're going to work on today is these problems. Okay?